Hello, we're now going to solve a problem from BGOpen 2018. It's problem E, expecting rain. In this problem you are given a distance and a time limit to a bus stop and a set of clouds and a set of roofs. Each cloud has a start and end time and a probability for rain and also a certain amount of downpour for each time unit. Each roof has a start and end point. The goal in this problem is to travel from your start point to the bus stop within the time limit and with the minimum expected rain. The first thing we need to do is to calculate the expected rain for each time unit. For each cloud we calculate the expected rain by multiplying the probability with the amount of rain. In this example we're using sample input 4, and the first cloud starts raining at 0 and ends at time unit 3. We also have 0.125 probability with the 32 as expected rain. And we fill this into our expected rain table. So at first we calculate the expected rain by multiplying the probability of rain with the amount of rain. That leaves us with this table. For time 0 and 1 we expect 4 millimeters of rain, but for time 2 we expect 20 millimeters rain because we expect rain from both the first and the second cloud. We expect 4 millimeters of rain from the first cloud and 16 millimeters from the second cloud. And for time 3 and 4 we expect 16 millimeters rain. We observe that while walking to the bus stop, some areas are covered by a roof, and it might be beneficial to wait while you're under a roof. We now need to calculate the minimum expected rain for each distance for each time unit. And we can do this with dynamic programming. We can now start working with our DP table, but first we observe that the initial value in each cell should be a very large number. In this case it's positive infinity. And we also observe that row 0, all the values are 0 because that's distance 0, which is under a roof. And we expect that the table entry dt should yield us the correct result. And we can now start filling in the DP table. We can now start working with our DP table, but first we observe that the default value should be a very high number. In this case it's positive infinity, and also that row 0, all the values are 0 because that's our starting point, which is under a roof. We also expect the table entry dt to yield us the correct result. And we can now start calculating the minimum expected rain for each time unit, for each distance. And we start by filling in the columns. Now I'm going to explain our DP table. This is our time and this is our distance unit. These cells are still infinity because they're impossible to reach. If there is no roof at the distance, then each cell at this distance will get the value of this last one plus the expected rain for this time. So here it's 0 plus 4. This 4 is the expected rain, and for this one it will be 20, which is the last expected rain, plus 16, which is the expected rain for time 3. If there is a roof at the distance, we calculate the minimum expected rain as the minimum of the previous rain at the same distance, or the rain at the previous time and distance plus the expected rain. So in this example we know that there's a roof at distance 3 to 4. So in this case it will either be infinity or 8 plus 20, which is the expected rain at time unit 2. So this will be 28. In this example it will be 28 because it's the minimum of the previous rain, which is 28, or 24 plus 16, which is 40. So that's why it stays 28. Then we can find our final result at this entry, the last entry in the DP table, which is 28, and that's the expected result.